I want us to write a proof now. I want us to write a proof because I wouldn't like to read the information for you. I would like us to go through this so that we understand it clearly, other than when I've got to read it for you. Right. I'm having two triangles that are two triangles which are in question here. I'm having my two triangles which are in question, which are triangles. Let me check what's going on here. I'm having two triangles in question here, which are triangle. My first proof will be based on triangle ABC, and triangle DBA. Let's quickly go back to our triangle. Let's quickly go back to our triangle. I'm saying what we are requested to prove. Our proof will lie. It's of triangle ABC. That's the biggest triangle, because remember I've said we have two triangles, ABC and triangle DBA. The bigger triangle and this triangle. Let's check what is it that we are provided with in those two triangles that we can use to prove the similarity of the two triangles. Fine. In the bigger triangle ABC, maybe I should not remove this so that we are always looking at it. Right. I would prefer to use this one. If you look at the bigger triangle, that is ABC. It is triangle ABC with triangle DBA. If we look at that, what is it that we can source out? The first thing that we realize that we can talk about is, for the bigger triangle ABC, we are looking at angle A. Angle A. Angle A in the bigger triangle. Angle A in the bigger triangle, that is this angle. This angle, angle A in the bigger triangle, will be equals to D1 of DBA. Remember, in the bigger triangle, when we started, we have said this angle is 90. Right. But we have also spotted that our D1 is also 90. So it means the angle A, that is A1 plus A2, remember this is what we have written, A1 plus A2 is 90. So the whole of A is 90. So it means in the bigger triangles, we have already spotted that this angle D1 will be equals to angle A. So that is what we can write it down. A1, no, not A1, we say A is equals to D1. What is the reason? Both of them are equals to 90, and the reason there is it's given. It's already given. Remember when we had that extension, when we had that construction, it made this angle to be equals to 90. That's the first thing that we can come up with from the two triangles which are in question, triangle ABC and triangle DBA. A is for triangle ABC. I wish I need to repeat this. Triangle A is for triangle ABC when angle D1 is for DBA. Both of them are equals to 90. The reason there is given. Fine. Let's look at angle B. In both triangles, we have angle B. When we look at triangle ABC, this is angle B for triangle ABC. And when you look at triangle DBA, we also have angle B. So we can always say angle B of triangle ABC, angle B of triangle ABC is equals to angle B of what triangle? Of triangle DBA. The reason for that is this is common. This is common. This is a common angle in both triangles. So we can write it down. It's common in both. I mean, we have triangle angle B in the bigger triangle ABC and angle B in BDA. So it means B is common. Fine. Let me not do this, sorry. Fine. Then let's have a look at angle C. What is it that we can talk about angle C for triangle ABC? Angle C must be equals to what? Must be in this triangle. Angle C is for triangle what? ABC. Must be equals to what? Must be equals to A1 of DBA. A1 of DBA. That is, this angle must be equals to that. Maybe people may not understand what is the reason behind. I mean, if we let's quickly do this. If this angle is 90 and this one is 90, fine. For triangle ABC, this angle is 90. This angle is 90. But now, if we look at A1 will not be 90. It will be 90 minus A2, which I can always write it as 90 minus 2, which I can always write it as what? Write it as what? As X. Fine. And also this one, if we check on this one D2 will also be equals to A2 will also be equals to 90 minus A1 will also be equals to 90 minus A1. Fine. Now remember, we say sum of angles of a triangle must give us 180. If this one is 90, then it goes without saying that this one must be 90 minus X. That is, if we, in case you are going to use the X as values there, that is what we tend to have. We tend to have. So now, if we quickly look at this, because I want you to be convinced that this angle is indeed equals to that. Because this one will be, in terms of X, will be 90 minus X, and that one will also be 90 minus X, and that one will also be 90 minus X. So, in principle, what I'm trying to say, if I'm comparing triangles ABC with triangle BDA, when I look at this angle must be equals to that. I hope we have captured that. But in terms of this, we are looking at C for this angle, which is equals to A1 for that angle. So the reason for that is sum of angles of a triangle. Remember, we say sum of angles of a triangle must always give you 180. Sum of angles, if we can just work on that one, it will give you 180. Fine. Sum of angles of triangle. Sum of angles of a triangle. That is the reason behind. That was the proof which was between triangle ABC and triangle DBA. Now, let us go on and take the bigger triangle again. What is this again? Triangle ABC with what triangle this time? With triangle DAC. With triangle DAC. Where is triangle DAC? This is DAC. Now this is the part. We are now looking at this part of a triangle. We are now looking at this part of the triangle. It's the bigger triangle with this part of a triangle. We want to check the information, compare the information, do with the information, because that information will eventually enable us to can prove that the triangles are similar. Remember, this is what we need to do. Fine. So I've gone as far as this and that. Okay, maybe in closing closing this one, I should have said, therefore, triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DBA. Fine. Triangle ABC is similar to triangle DBA. DB DBA. Why? Because we have established that in the two triangles, angles are equal. So it means that the two triangles are similar. This is the first similarity that we come across. That the two angles, the three angles from two triangles are equal, and because of that we can come up with this conclusion. This is the first part of the conclusion that we come up with. Now let us go to the second proof, wherein now we are going to look at triangle ABC and triangle DAC. That is this triangle DAC with a bigger triangle ABC. What is it that we can source out as an information to use? The first thing that I can spot in this triangle is that angle A, that is for the bigger triangle A of ABC, is going to be equals to what? Is going to be equals to triangle D2, angle D2. It's going to be equals to D2. The reason is both of them are equals to 90. And fortunately we are given that. Their magnitude is 90. And that is what is given to us. Fine. That is the first pair of angles that we have identified to be equal in the two triangles. Triangle ABC and triangle DAC. That is, this angle is equals to the bigger angle. Fine. The second part of that, just like we did with B. Remember, with the first part we have said B was common in both. B was an angle for ABC and was an angle for DBA. So it means we can say the same with C. C is an angle for ABC, and C is also an angle for DAC. So it means C is common in both triangles. C is equals to C, and it is common. It's a common angle in both of them, in both triangles.